Hi, I welcome you to this introduction to electric vehicle section. In this section, we are going to discuss about what is the basics of the EV and how we can understand the dynamics of the EV and how we can model the EV in the Matlab Simulink. So keep engaged with the entire video, so you will definitely get to know about all the information. And if you take a transportation systems, the conventional vehicle only plays a major role so far. Right? So in that, the conventional vehicle has a conventional fuel. So due to lack of conventional fuel availability, so the entire EV market is our transportation automobile industry has moved to the electric vehicle systems. So in that aspect, again, due to advancement in the technology, sometimes the people are used conventional vehicle, conventional fuel as well as that electrical resources. So initially they have used for start and stop functions, and after that they have added a few more functions called brake energy regeneration and then torque assistance during the acceleration time, so everything. And again, so nowadays actually in the advancement of the power electronics and then advancement of the technology, so the entire transportation system has been converted to the electric vehicle systems. And again, if you take future of the transportation system will be, one is that electric vehicle and another one is that autonomous vehicle, that is unmanned vehicle systems. So UV and EV. So if you start your career in these two segments, so that definitely you can get a better options. And in the electric vehicle system, so there will be a absence of the conventional fuel and conventional vehicle parts called engines and other lubrication systems and all. But the vehicle body and basic models, so everything will be there, except the conventional vehicle component called engine and other lubricant parts and all will not be available. So instead of that, battery and electrical motor and onboard chargers. So the three component will be available in the electric vehicle system. So we can charge the vehicle from the charging stations. Right? So let us check one by one what are all the things and then how we can develop the component. And so what is the pros and cons of the EV systems? See, actually, first point is that environmental fact. The environmental fact is absolutely, it's a friendly environmental component. And the cost, see, actually, there is a maintenance cost will be absolutely very less. But the initial manufacturing process cost will be huge, because the initial investment taking more, right? So in that aspect, the cost plays in the two different role. And again, it's very easy to control the vehicle and energy efficiency due to advancement in the technology in the battery segment and then motor segment and advanced power electronic controllers. So we can get the maximum, we can extract maximum efficiency from the resources. And again, there are some limitations. One is the thermal limitations and the charging station infrastructure. As of now, the infrastructure for the charging station is very, very less. But if the entire country wants to move to the EV system, then the infrastructure must be improved in 200 to 300% than this situation. And the range of distance. So far, the people have tested about 450 kilometers per single charge, but it's not sufficient for this EV applications. So in that aspect, again, we have to work to increase the charging range distance per charging per cycle. And again, one more limitation is the temperature. See here. Because the battery is the main resource to the vehicle. So once if you charge the vehicle, charge the battery, then there will be a chemical process will be happening inside the battery. So in that condition, there is a chance to change the temperature rise enormously. So again, so due to that process, the temperature is again a critical parameter to regulate within the vehicle. Right? And so what is the electric vehicle components? The first one is the vehicle structure, that is the body and then wheel structure. And second one is the motor, battery and then power control unit and onboard charger. And in addition to that, assembly like other essential components called like a mirror and other wiper control and the dashboard clusters, everything, electronic clusters, everything, and other sensors to facilitate other luxury. And suppose if you go in detail about the EV parts, so these are some parts. So first one is the body. So the body is driven by the motor. The motor is controlled by the inverter, right? So the inverter will take a power from the battery bank. Again, the battery will receive a source from the onboard charger. So that charger is powered up with the charging stations. So this is the single line diagram of the EV parts. See here, the process flow will be from the charging station to onboard charger, from the onboard charger to battery bank, and from the battery bank to inverter module, and from the inverter module to motor, and finally that motor power will be connected to the body. So finally we will get a movement in the vehicle. Right. So here again there are lot of motors are there. So each and every manufacturers are using different type of motors to achieve their standard ratings. And similarly, the inverter here, the inverter is used to control the motor at desired speed range. And so here the battery bank. So generally for EV systems, so far the people are using lithium-ion battery. So in the lithium-ion battery, there are in the market you can get any range like 12 voltage, 24 voltage, 60 voltage, 72 voltage, 80 voltage, 100 voltage, 96 voltage. So in this range, any range you can get it. So because actually it's available in the single cell. So you just buy the model and then add into your either series or parallel based on your requirement. Right? And here this is the onboard charger. So people will call like a OBC. So this OBC will take care about that to charge the battery and also the power factor corrections. Right? And this charging stations. So there are three type of charging stations are there. One is that domestic charging station. So it will take 17 to 20 hours time will take to charge the full battery per single time. Similarly, the commercial charging station is it will take 8 hours to reach the maximum battery capacity. And again, one more that is the fast charging. So the fast charger will it will take 20 minutes to charge the full battery. So like that, you can get a variety of options. And how we can drive the motor, that is how we can drive the vehicle. So that is the vehicle body. So the vehicle body will receive a power from the motor. So the motor is controlled with the help of inverter, that is a motor controller. And again, this motor controller unit or inverter is powered up with the battery. And in addition to that, the control signal, that is called the drive signal or drive cycle is applied by the driver unit. So from that unit, the signal will be converted as a control signal. So once we vary the control signal, based on the control signal, the motor will get activated. So whenever it receives a control signal from the inverter, then we can get a movement in the vehicle. Right. So here, how we can design a vehicle. Right. So in that condition, so first you should know the propulsion power. How much power is required to move a vehicle from the standstill position. Right. So that is the starting point of your vehicle EV design procedure. Right. So in that aspect, so first you should know the weight of your vehicle and total passengers load, that is the load, maximum load capacity. right? So that from the two factors, you can identify your vehicle body. So once if you got these details, then you can go for the motor size, because from this total weight only we can arrange the motor, which motor and what range we have to use it. Once if you know the motor size, then you can go to select a battery capacity. Once if you decided the battery capacity, you can go for the charger. So the design cycle will get come to end. And here, so if you want to understand the vehicle motor power calculations, so first you should know the dynamics of the vehicle. Suppose if the vehicle is in at a very standstill position, so there will be a two force. One is called the friction force. From the suppose if you want to move a vehicle from the standstill position, so in that conditions you will apply the push force, right? So that is called the propulsion force. So to that force will be the direction. I mean, it will be the towards your vehicle directions. And in the opposite directions, the friction force will be there, because the wheel is laying on the road. So that is called the friction. So there will be friction force. So let us check in detailed manner what are all the other forces will be there, and how we can add or how we can take care about those factors, and then while you calculate your entire motor power. If you take this diagram, so in this diagram, this is called like a free body diagram. So the propulsion force is the resultant force you need to apply on the motor side, right? To overcome this opposite forces called gravitational force, friction force, and aerodynamic drag forces, right? So the total power required is that a total tractive force, that is the summation of all the forces into velocity of the vehicle. So how much velocity at what range you should drive your vehicle, right? Suppose if you know these two details, from this you can calculate the total motor power. So let us check what are the total tractive forces. So this is the forces on the vehicle. So the first force is called rolling resistance force, and aerodynamic drag forces, and hill climbing force, and acceleration force. So in the acceleration force, there are again two things. One is called the linear acceleration and then angular acceleration. So let us take one by one what all is rolling resistance. Suppose if you take this vehicle, so this vehicle is traveling on the road. So the road will not be at any point of time, the road will not be at an even space. So either it will be a up gradient or a down gradient, right? So, and the road again, the entire travel period, that road will not be at the same conditions. And again, due to these factors, so some additional forces are acting on the body. The first force is called the rolling resistance force. So let us check what is the rolling resistance. It is one of the forces that act to oppose the motion of a vehicle. It's a constant. So the rolling coefficient is a function of the tire material, structures, and temperature of the tire, and the tire pressure. Similarly, the thread geometry, that is a tire design center, and the road roughness, how much road is the roughness, and the material of the road, and the presence and absence of liquid on the road. So these factors, combination of these factors, we are going to decide the coefficient's value. It's a constant value. And again, for prototyping development, you can fix it this as a constant. So based on this value, that is called mu RR, right? So this is the rolling resistance constant or coefficient. And M is nothing but mass of the vehicle, and G is nothing but gravitational acceleration constant. So once if you know these details, from this you can calculate the rolling resistance force. Some typical values for the rolling resistance constant, that is called car tires on concrete or asphalt. So 0.013, right? So that will be a very less constant value. If it is a maximum, so it depends the road roughness, right? So you have to take care about all the points like our road conditions, and then upgrade or downgrade values, and tire type of your tire vehicles, right? And similarly, what is that aerodynamic drag force? So the aerodynamic drag force is nothing but while you travel in the car, so there will be a the air forces will be applied on the vehicle, right? So it will be generally the front side will be the high pressure, and then lower back side of the vehicle will be the low pressure. So the high pressure air will suppress your force. So from this point you have to overcome, or you have to apply more power to overcome this pressure. So that is a formula to calculate all the things. That is aerodynamic drag force, FAD is equal to half rho, that is the air density, and CD is nothing but drag coefficient. Again, this is depends on your design of your vehicle. So it also has some constant values. And the frontal area. See here, if your vehicle front area is a flat surface, then this force is a more this value will be increased. Suppose if it is increased, then obviously you need more power how to apply, right? So as much as possible, you should reduce this value. Try to reduce this value so that you can reduce the motor power and velocity of the vehicle. So what is the maximum velocity of the vehicle? So if you know these details, we can calculate the aerodynamic drag force. And this force is an so this force is will be it will increase the square of the speed. So in that conditions, if your vehicle is at maximum speed, then if you want to drive at a maximum speed, so there will be a constant needs to be calculated properly. And some constant typical values is, so based on this design, so as of now, this design is a very lowest value it has. So CD, that is a drag coefficient value 0.32. So you can take it. So based on the vehicle design, this value will get varied. And hill climbing force. See, actually, if you take this triangle diagram, so this is your flyover, or else you can imagine your road type. Suppose if your vehicle is in the upgradient, so then the formula to calculate the upgradient is that m into g, that is weight of the body and then gravitational force and sine of theta. So the theta is nothing but the angle between the length and rise and then run. So generally the ratio must be, that is the maximum theta about 45 degree. So you can take a worst case scenario. So at what is the maximum angle? So then based on that value you can fix the data. And acceleration force. Suppose if you want to push the vehicle, so there will be two kind of acceleration. One is called the linear acceleration and the angular acceleration. So the linear acceleration is nothing but, so it's like a Newton's third law. So if you apply the force, then the resultant opposite forces will be there. So that is called F is equal to m into a. And the angular acceleration, nothing but if your motor is coupled with the gear and then it will directly connected to the wheel, right? So there will be angular acceleration. So to calculate those data, that is I g square a divided by r square into eta q, right? See here I is that nothing but moment of inertia of the vehicle, and the g is the gear ratio, a is the acceleration, and r is nothing but radius, and then efficiency of the gear. So these are the formulas. Suppose if you have all the details with you, then you can start your vehicles design. And the total power required to drive your vehicle, nothing but, so that is the total power, P is equal to F into T, that is the total tractive power, tractive force into velocity of the vehicle. That is the summation of rolling resistance force and aerodynamic drag force, hill climbing force, and linear acceleration force and angular acceleration force. So here for prototyping applications, you can take a rolling resistance and then aerodynamic drag force. So remaining and all, if you consider your vehicle is traveling under that smooth surface manner, so you can avoid that heel clamping mode. Suppose if you want to add those components, yes, you can add it. So this is all the formula, you can use it. And see, actually, I have a basic data, that is the total weight of the vehicle and width of the vehicle and height of the vehicle. If we know these details, so from these details, we can take it as a constant, some coefficient like a rolling resistance, I took a 0.02, and air density like 1.25 kilogram per meter square, and the drag coefficient 0.30, and the gravitational force or that is that G is nothing but 9.8. So now I want to run my vehicle at 40 km per hour. So in that conditions, first you should convert kilometer into velocity, that is the meter per second. Kilometer per hour into meter per second. So that is the 40 into 1000 divided by 360. So once if you get, then the velocity of the vehicle is 11.1111 meter per second. And the frontal area, that is A, is multiplication of width and height. So in the conditions 1.5 meter square. If you know these details, you can calculate the total power. So that is the total tractive force. Ft is equal to 170.15 Newton meter. I will share you the Excel sheet. So from this you can calculate your various values. So just take this Excel sheet, you just download the sheet and then you can use it. See here, width and width, height. So remaining things you can use it whatever you want. 0.02 and 0.3. So whatever it has is you can take it. And the speed. So you can change the speed like 40 km per hour or 50 km per hour. Suppose if you take a 40 km per hour, so the total tractive force is 219.148, and the total power is that about 2434.97. Here, see here, 2434.97 watts. So in that conditions, you need a motor power about 2.5 kilowatt. Alright, and suppose if you want to run the maximum speed of the vehicle is about 100 km per hour. So in that conditions, the 9463.22. So that is the maximum value. So here 9463.22. So that much of power is required to drive the vehicle. So in that condition, you have to choose the 10 kilowatt motor. If you choose the 10 kilowatt motor, so based on this, again you can take how much current you want to handle it. So like that you can take it. So if you have a 360 voltage level, then the current will be the 22 maximum 22 ampere. Again, depends the vehicle load. You can adjust these two values. Let us check one by one on this next 30 days challenges. So keep engaged in the entire series. So definitely we can develop the entire vehicle on step-by-step manner. Alright. So this is the basic motor power calculation. So from this we can kickstart our design. And if you change the motor power consumption, like if you want to increase your vehicle capacity, like 40 km or 100 km or 160 km per hour, then obviously the motor power consumption will be drastically increased. So from this graph, you can understand how much power you need to achieve on the particular range. And let us take sample data. That is rider mass. So this is the two-wheeler vehicle data, rider mass and vehicle mass, that is at 237 kg and then 80 kg. So the total weight of the vehicle is 237 plus 80, and the CG is nothing but height of the vehicle, and drag coefficient 1.2, that is you can choose whatever you want, and the frontal area, front axle dimension, and then rear axle dimensions, and front area. So if you multiply those things, then you can start one two-wheeler free body diagram. So let us check let us develop one two-wheeler, so not a four-wheeler. And so this two-wheeler, again here we are going to develop just a body and then tire. If you keep your vehicle in the flat surface, let us check what it will happen. Similarly, if you put your vehicle under that up gradient, so down gradient, then what it will happen? Either it will be the speed will be the positive or negative, and up gradient. So like that we can check in the Matlab Simulink. And again, these are all the constant parameters for the tire component. So you can by default the Matlab will give you these things. And the rolling resistance constant, you can choose it whatever. Let us open the Matlab and go to Simulink block and open the new model and save name like vehicle body, whatever you want, you can say, and double click over the work area and search vehicle. So you will get a vehicle body and vehicle 6 DOF and a vehicle terrain sensor, so everything will be there. You just take vehicle body. If you take vehicle body, so there will be some components. I will tell you what are the each and every components where you have to apply those details. And similarly, we need additional two more components called tire block, right? Tire and sensors. We need to measure whether the vehicle is running or not. So everything you can check. See, if you take this block. So there are some terminals will be there, right? So that is NR, NF, and H, V, beta, W. So the beta is nothing but that is the angle of gradability, and W is nothing but wind velocity, and V nothing but velocity of the vehicle. So we can say we can measure the vehicle velocity. And H is nothing but the hub. The hub is nothing but the vehicle is connected with the wheel. So that is the hub. And NR, that is the rear axle forces and then front axle forces. So here you have to connect your motor to drive the right. So once if you connect the motor to this component, then only the tire will receive a force to rotate it. So let us check. Let us feed the data how the things will be. See here, as per our calculation, as per our data, that is 80 plus 237. That is the weight of vehicle. See here, 80 plus 237. And the number of axle, since it's being a single two-wheeler, so we need a two. That is make it as a 2, and that is horizontal distance from the CG front axle. So let us check the value. That is at the horizontal front axle. Yeah, that is 1520 millimeter, and real axle 4400 millimeter. Feed the data. 1520 and 1400, and then CG, that is a 254 mm. Here you can adjust those things. and gravitational acceleration 9.81, and the drag coefficient you can check it, and then frontal area. So that is the frontal area 1.33 meters square, and the drag coefficient. If you have the drag coefficient, you can keep it here. So like a drag coefficient 1.2, and air density, like air density, you can check it. You can take it from the Excel sheet. So 1.125 or whatever you want, you can take it. Then remaining thing, no need to change anything. Just apply here. And so now we needed two numbers of tires. Just to take a tire, again search in the library block, take a tire magic formula. You take tire magic formula and rotate it. Yeah, so rotate like this, and see here, here you don't need to change anything. So you can, if you have a radius and then other components, you can take it. And here you can add the rolling, that is the radius of the vehicle, and rolling resistance. If you have, you can add that rolling resistance. How much rolling resistance you have? The rolling resistance 0.005. And take one more model and connect hub between these two. Let us interchange the component. Flip. Yeah. And so now the axle is, now we are not going to connect a motor. So in that conditions, it will be a free end, right? And this is the force for the vehicle, front wheel and then back wheel. And these two are the sensor values. So now you can, no need to measure this tire data. Let us take a terminator component of the PS terminator. Take this one. So these entire components are all SimScape components. Alright, so the system will be like this only. Yeah. And see here, now we have to add, apply these two values. Suppose what is your wind velocity? If there is no any wind velocity, you can keep it as 0 for W terminal. And similarly, the beta, nothing but gradability value. So the gradability value you can apply via the constant. Take a search constant block. So there are two type of constant blocks. So this is the sim power system block. So this won't apply here. So straight away you can take PS constant. Yeah, see there will be PS constant. You can connect to here. So here you can take, you can apply the degree value. First you have to choose the degree or radian. So if you take a radian, then if there is a upgradient, then you have to apply positive value. If there is a downgradient, then you have to apply the negative values. Right? If your vehicle in the downgradient, then the vehicle will be in the positive speed. If it is an upgradient, then the vehicle will be the negative speed. So whatever it may be, so let us define the degree, like whatever the degree, either it is a 20-degree deviation or 45-degree deviation from the ground level. And pi by 180. So that is the conversion range. And again take same graph, same component, and connect wind velocity. So here the velocity, wind velocity, you can check whatever you want, or else the constant you can keep it 1 or 0, whatever you want. And hub we have to connect the wheel, and this is the sensor module. Just to take a scope block, here we are going to measure the vehicle speed by the scope. The scope we cannot connect directly, so because the scope is the power system block set. So now we need a additional converter to convert these two values, and take a PS to Simulink converter. See here you can connect SimScape block and to the Sim power system block. And again, we need a rotational free end because the vehicle is not connected anywhere, like motor power. So in that conditions, take a rotational free end. Like a pendulum. Yeah. So now the wheel is connected at the rotational free end. So here I no need to connect. And again, you have to connect the solver reference. Take a solver configuration. So just to connect, because this is the reference for this entire block. So you have to connect. So if you run the simulation without this value, then we cannot get the output. To just run this, now we have to run the simulation for 3600 at least 500 seconds or 100 seconds, then only we can get output. So let us keep a maximum value. So let us take what is the positive or negative values. See here we have applied positive value, that is called upgradient. The speed will be in the negative slope. So this is the scope you can use for your variable measurements. Right. So see here the speed is in the negative speed. Similarly, if you change the gradients to negative, then the vehicle will be in the positive direction. Like that, we can kickstart the EV modeling in the Matlab Simulink. So try to practice this entire examples, and finally you will come to know about it. You please practice this example and get the output, and then paste the output in the video comment box. And so by doing this practice only, you can learn the electric vehicle modeling concepts. So here I am here to help you on stage by stage for next 30 days. So you please engage with the entire series. If you are interested in the internship, you will get a certificate by email. For that one, you will get an internship program. So here you can join the VP group, WhatsApp group, and you will get directly. You can get a support from me. How to, how to do and how to develop your own vehicle and all. So that is the cost is only 590. The link is available in the description box, so you can get. And if you are interested, is 11th February 2023. 11th February 2023. Right? So you can join over there. If you have any doubt, you can ask me. I will try to give you the answers. And this is my WhatsApp number, so you can post your queries here also. I will give you. I am here to help you. See here, after joining in the internship, you can directly go to the our LMS website. So here you can get a TV bundle. So see here you will get a complete classes. Yeah. So you can download the Matlab simulations. You can download all the presentations, everything.
You can download the PPT, you can download the simulation files, everything you can get it in the internship. Whereas for the YouTube sessions, you can post your queries. You just follow the live sessions and you can practice on the live only. Yes. So all the sessions are available. If you are interested, you can go and join the internship. You can download it. All the notes are available to download. Thank you, participants. Thanks for valuable time. If you have any questions, you can post me. Just take my number. This is my WhatsApp number. So 9840974408. So if you have any queries about your research activity or your laboratory requirements, you can post your queries here. Thank you, participants. Thanks for a valuable time. Thank you once again.